Okay, now that we've looked at how to solve a proportion, we're going to move on with similar figures. Okay, 7.2, Similarity Transformations. Similar figures, it says, are figures that have the same shape, but not necessarily the same size. And we've already shown you how we dilate figures. We can either make them bigger that have large scale factors, greater than 1, or we can make the figure smaller, but they have the same shape, they just change in size. Okay, that's what similar figures are. These two polygons here are similar. It says polygons are similar if their corresponding angles are all congruent. So the angles of the figures are exactly the same. And you can see that with the arc marks. Here's angle A, this angle over here, they have the same angle measure. And you go through the figure and each corner matches up and has the exact same angle measure. So angles are going to be congruent. But the side lengths, the reason the shapes are different is if we compare the side lengths. Here's 80 and here's 40. They are different, obviously, but how much different? Well, 80 from 40 to 80 is a times 2. So if we started with this figure being our original, we get twice as big to get to 80. Now that proportion or that scale factor has to be the same all the way throughout the figure. So if I take 38, if I double it, do I get 76? The answer is yes. If I take 41, and this side over here corresponds with it, if I double that, will I get 82? Answer is yes. Okay? And the last one, this side corresponds with this side over here. If I go twice as big, 47 times 2, I do get 94. So in each case, each side is twice as big. Because that's a consistent ratio throughout the figure, we would say, yes, those two figures are similar to each other. Okay, and it goes through that explanation. Similar polygons are named the same way that we name congruent polygons. Okay, so this is important. When you name figures similar, since they started with A, they went up to B, C, and then D, they started down in this corner. So which angle over here was corresponding to that? Well, it's the angle that has the same measurement. So we have to start with E, and then we'd have to go up to F, G, and H. So you have to name the figure, just like you did with congruent triangles. You have to line up the corresponding pieces. Here's the difference, though. With similar, we don't use a congruent sign like we did. The symbol for similar is just one wavy line. So this says polygon A, B, C, D is similar to polygon E, F, G, H. Okay, and we've already looked at how we line up the ratios and they all come out to be twice as big. The similarity ratio was 2 to 1. Each side of the larger figure was twice as big as the smaller figure. Okay, you're going to use that idea to find the lengths of missing sides. Okay, so these two triangles, they tell us, are similar. Okay, since we know they are similar, it means their sides have to be proportionate to each other. Their angle measures are equal, are congruent, they're exactly the same, but the sides have to be similar. So you want to find a set of sides that you know both sides for the two figures. So if I look at this side here on the left, I know it's 3.5, and this side on the left is 6. So I'm going to write a ratio for those two corresponding sides. I'm going to say 3.5 over 6.0. Okay, and I'm going to set that equal to, I want to find the value of x and I want to find the value of y. Okay, so if I want to find the value of x, it came out of the triangle that had the 3.5, so it's going to go in the numerator because 3.5 is in the numerator. These two sides are coming out of the same triangle. Over, what side over here corresponds to that? Well, hopefully you said 7.2. So I can set up that proportion to solve, to figure out what the side x is going to be. Okay, I'm going to use cross products to solve. So I would take 3.5 times 7.2. Okay, and I get 25.2 on that equals, and then I'm going to set up this product. So I've got 6.0 times x. How do we solve that for x? we're going to divide by 6.0. And we get a value of 4.2. 4.2 is equal to x. So I know that this side length over here would have to be 4.2 units. Okay, I'm going to do the same thing to find the value of y. I'm going to still use those same two sides that I knew both of them were. So I'm going to say 3.5 over 6.0, and I'm going to set that equal to, I need to find y. So these two sides correspond together. Y is involved. 1.4 comes out of the same triangle as the 3.5. So this time I have to put that, since this is on the top, this piece has to be on the top. They're coming out of the same triangle. Y goes on the bottom this time. And again, I'm going to use cross products to solve. I can take 3.5 times y and set it equal to this product. Okay, I've got to take 6.0 times 1.4. I get 8.4. Okay, how would we solve that for y? We're going to divide by 3.5. Okay, my answer for y equals, it's 2.4. So y's distance is going to be 2.4. And again, don't worry about a lot of times things aren't going to be drawn to scale, so don't worry about whether that looks right or not. But I would go back and make sure I have my proportions set up. But we're going to set proportions up to solve for missing side lengths. Okay, to check and see if the figures are similar or not, you'll need to check that all angles are congruent and all sides are proportional. Okay, so they're asking us, they're not telling us that these two figures are similar, they're asking us if they are. So the first thing you want to do is you want to check out and see if the angles line up, if the corresponding angles are congruent to each other. So this angle here is 61, this angle that would correspond to it is 61. Okay, 115, I got 115, 108, 108, 76. Okay, that's easy to check out. You can see by the picture that all the angles are congruent to each other. So that's the first thing that has to happen for figures to be similar, and that works out. Okay, now we also need to check out the sides. So I'm going to set up this ratio of 6 over 4. This side 6 corresponds with this side 4. Is that ratio or is that proportion the same as, pick another set of sides. This would be 13.5. It's going to correspond to 9. Since 6 is on the top of my ratio, I've got to put 13.5 on the top of my ratio. 9 goes on the bottom. Now, if that's proportional, we'd say that's proportional if the cross products are equal. So I'm going to take 6 times 9. I know 6 times 9 is 54. Does that equal 13.5 times 4? Yep, I get 54. So that one checks out. Okay, so these two sides and these two sides have the same proportion. Okay, let's try another one. I'm going to say 6 over 4. 6 is to 4. Is that the same as 7.5 to 5? These two correspond to each other. 7.5 over 5. And again, the side 7.5 is coming out of the same figure with 6, so they're both in the numerator of my ratios. Okay, I'm going to check out this cross product. So 6 times 5 is 30. Does that equal this product? Okay, 7.5 times 4. Okay, that's 30 also. Okay, so that side checks out. Okay, last thing I want to do is I got to check out this last side also. So I'm going to use 6 over 4. Okay, again, this is 6, corresponds to 4, and you could use any of the ratios. I'm just using 6 and 4 all the time. You can pick any of them to use. But does that equal 18 over 10.5? Okay. And again, 6 and 18 are coming out of the same figure here. 6 and 18 come out of the same figure. They got to be in the same position in your proportion. Let's look at the cross products. Okay, 6 times 10.5. That's 63. Does that equal 18 times 4? Okay, that equals 72. When you find something that's not equal, that's not proportional. So this would be, this is all angles. Yes, we found that those were proportional, but the side lengths weren't, okay? That was a no. So it's walking you through those steps. Those are not similar figures because all the sides don't match up in the same proportion. So we would say no. All right, so you've got a worksheet that you can work on. Most of that worksheet you're going to be determining what a missing side is, and then I do think on the back side you have to decide whether figures are similar or not.